All right, so in this video, we're going to be talking about completing the square. This will be completing the square focused on getting a vertex form of a quadratic so that we can see the transformations, not necessarily to solve a quadratic equation, which is often what you'll find videos on completing the square surrounding. So we're going to focus on just getting it to vertex form. And the first case we're going to look at is when a is equal to 1. So that means our leading coefficient, the coefficient of the x squared term, is equal to 1, or there's nothing there at all. That's the same thing. So our goal is to get this perfect squared term, which means there's going to be a perfect square trinomial. And so we're going to create that perfect square trinomial out of the first two terms. Some other term will add in, and then to keep both sides of the equation, quote unquote, equal, we'll subtract out what we added in inside of that. So the first perfect square, the first section in parentheses will turn out to be a perfect square trinomial that we can reduce to be a squared binomial. So to find that, always what we're going to do is we'll take this b term, b divided by 2, and that will be this term. So this will be -6 divided by 2 is -3. And then the term for what we add back in and we subtract out will be b over 2 quantity squared. So -3 quantity squared is equal to 9. So we'll add in a 9 and subtract out a 9. So it turns out that this, because that ends up being 0, this is actually x minus 3 squared. This was actually a perfect square trinomial already. And we could have noticed that back at, let's see, can I have my pointer? We could have noticed that back here when we said -3 squared is 9. Hey, that's just what my coefficient was anyway. This trinomial is the same as this one. So that's a point where you could have recognized it already. Let's do another one with a not 1. Actually, let's go ahead and just dive into where a is greater than 1, or absolute value of a is greater than 1. So here our a value is -3. And what we're going to do is first check, is there a GCF? Now, 24 is divisible by 3, but 4 is not evenly. So we can't factor out -3 as a GCF. We're going to have to deal with it some other way if we want to complete the square. So what we're going to do is group those first two terms like we would have if we were going to complete the square normally. I'll leave some space for something to be added in. We're not quite going to do that, but just so you recognize the parallels between the steps. And in this term, we're going to factor out this -3 from both the first and second terms. So really what we're going to end up with is -3 times x squared. 24 divided by -3 is -8. Remember, check, -3 times -8 gives me +24, so that is the factor that I want. And then I have this blank. I still have my -4 and my plus blank. So when I complete the square, I'll bring my GCF down. Never drop your GCF. Once again, I'm going to say, okay, half of b gives me this term. So x minus 4 is my squared binomial term. And -4 squared gives me +16. That's what's going to go in the blank. That's what I'm adding in to make that trinomial a perfect square trinomial. And since I added in 16, I gotta subtract out. Excuse me, this should be a subtraction sign. We'll go back and fix that in the previous step as well. Okay, since I added in 16, I gotta take out 16, so that only makes sense. All right, so what's left, since what's in parentheses in this step and this step are equal, what's left is -4 minus 16, which is -20. But wait, if you actually FOIL this out, you're not going to get the right answer. That's not all, because this 3 would get distributed to this 16. I didn't just add in 16. I added in 3 times 16, negative 3 times 16. So I'm going to have to multiply that minus 16 by negative 3 before I do any simplifying. So to simplify, that minus 4 is going to stay the same, and now we are adding in 16 times 3. And that is 16 plus 16 is 32, and 32 plus 16 is 48. So we have positive 48, because that was negative 16 times negative 3, so we get a positive 48. And so we are now working with, our final answer should be negative 3x minus 4 quantity squared plus 44. And all of these are still f of x equals. These are all equivalent expressions. We kept every step equivalent. So let's do that again without the hesitation around making sure we multiply by this. Every time at the end, we're going to, if we have a coefficient here, we're going to multiply that coefficient here. So let's do one more example. Let's do a g of x. That is 2x squared minus 5x minus 1. Again, I check first if 2 is a GCF of all the terms, of all the coefficients, and it is not. So what I'm going to do is I'm going to group that 2x and that negative 5x together with a blank, adding 1, subtracting out another blank. That's still g of x. What I'm going to do is I'm going to factor out 2 from both of these terms. And you might be saying, Ms. Rogers, I can't, how do I factor 2 out from 5? 2 doesn't go into 5 evenly. Well, what we can do is have fractions. Fractional coefficients are not illegal, they are allowed, and sometimes they're helpful. So what we're going to do when we factor out that 2, again, we ask ourselves 2x squared divided by 2 is just x squared. We're going to say the same thing for the next coefficient. So negative 5x divided by 2 is 5 halves times x. If you distributed that 2 back in, you'd see the 2's cancel, simplify out, and you just have 5 again. So that's exactly what we want. Now, what I end up putting in that blank, I've got to remember, since I've factored out that 2, I've got to multiply what I put in this blank by 2. So I'm going to go ahead and put that there. And now let's figure out what's going in our blank. So our perfect square binomial, what's going in this blank will be half of 5 halves. Well, what's half of 5 halves? Half of something is like multiplying by 1/2. Remember, of means multiply. So half of 5 halves is 5/4. And 5/4 squared, how do we square a fraction? Well, we square the top and we square the bottom. So that is 5 squared over 4 squared, or 25/16. So what's going in my blank is 25/16. Don't be afraid of the fractions. Don't be afraid of the fractions. Okay, so now I've got some simplifying to do. I'm going to bring down that -1. I'm going to distribute my 2 to the 25/16. So 2 times 25/16 is 50/16. And I might rewrite this 1 in terms of 16ths. That's 16/16, right? So now that they have a common denominator, I can combine them. And that is 66/16. 66/16. Apologies for the noise. And so that is your process. If you have a fraction, definitely check if it is able to be simplified. So take a second to yourself and say, is 66/16 something I can simplify? And it turns out we can't. That does not add, 16 does not go evenly into 66. And if you know your powers of 4, you'll know that 4 to the 3rd is 64. That is 4 times 4 is 16, and 16 times 4 is 64. So 66 is just a little past 64, so it does not simplify, and that is your final answer. Thanks for watching. If you have any other questions about completing the square to see transformations, please come see me during one of the times listed on my availability or ask during class. All right, thanks, bye.